Alright, let's go ahead and make this video before I get too lost in the woods here. Hello, and this is my next video on this channel, Learning and Development. This video I don't have a lot of new things to show, but I am going to be showing a lot of things that I have learned about how games are structured. Mainly how game info is saved and loaded, so that when you close the game, game data persists. And I'm going to show you a mechanic that I made that lets me randomly select weapons from a list. But before I get into the game I'm working on right now, I wanted to show you some other stuff that I have learned the past few weeks. But yeah, the first being this platform style game. The game dev tutorial showed me the basics of how to do tile sets, basically how to build a side-scrolling platform style game. I didn't spend any time on this game because I personally do not like these games, these side-scrollers style platforming games, but I just walked through the tutorial. I watched the whole thing but didn't really work on it or improve on it at all. What you're seeing on screen is just like all the basic things it taught you how to do, just thrown together. But it's much the same. It's all just using the in-engine Godot area signals to do pretty much everything. The player has an area, the traps have an area, and when one enters the other, something happens. And that's basically all that's happening. But I did learn quite a few things from doing this project, mainly shareable scripts and groups. Creating a shareable script isn't too hard. You just right click in the file system down under bottom left, create a new script, and now you have a script that is linkable to any scene you make. In this game they showed you how to do it with all the traps you make. All the traps run the same script. That way you don't have to copy paste the same code for every trap you make. And the second is groups. I'm still learning this, so I won't go too far into it, but you can put scenes into groups, then in code refer to things in that group. For example, if this thing is in this group, execute code, and if not, don't. That being said, the actual group system is here. You can make new groups like this, enter the name, you can make them global or scene wise, and then by putting them in a group, you can essentially do something like this. This is something that the tutorial teaches you how to do, but you can basically use the group traps to execute code. And in this case, we're putting every node, get all the nodes in the group into the variable traps, and then we're using a for loop that basically goes through all the traps in the group and executes this code here, which is a signal. I can't tell you a whole lot about groups because I haven't really worked with them so much, but what I am using them for is safeguards. If I have a section of code that I just want to execute when the player enters the area, not when other enemies or whatever enters the area, I can make a group called player, and then if in the code I can say something like, if the area is of player group, then execute this code. So I'm using it as like a safeguard right now. This is an example of a signal that's in a player script in another project I'm working on, and this is basically saying if the player enters an area that belongs to the group XP, which is basically an XP scene that gets dropped when an enemy dies, execute that area's die function, which basically makes it despawn, and then it does all this other stuff too. So it's like a prevention system, so that if, like, say an enemy enters the area, you don't really have to, it's a safeguard system. You don't have to worry about collisions and other crazy stuff like that. And just another example, let's say that I didn't have the if area is in group part, and I just didn't have that at all, and I just executed the area.die without any kind of if, safeguard. What would happen is, as soon as the player would go into an area, it would try to execute the area.die function, and if that scene didn't have a die function, it would throw an error, or it would, if it did have a die function, you couldn't specify what exactly you wanted to happen. So that's what groups are good for. I can say XP group, and everything relating to XP I can put in that group. So yeah, the next game is this Zelda style adventure type game, and again, I do not like these types of games, like this solve puzzles to unlock a door style of games, which this is basically that. It doesn't look anywhere near as good as what you can make it from the tutorial, but I kind of just watched this too. But at least it touched on the basics of moving rocks and going in and out of scenes, and a very basic combat system using a sword, which, I mean, everything is more of the same. It's just area 2Ds and collisions, and when something collides or when an area enters an area, execute whatever you want. I'll link the lesson down in the description, but this is an 8-hour course, so I'm just going to skip all the details about this one because, for one, I did not like the way this lesson was structured. It's the complete opposite of everything else I've learned. It uses a bunch of resources and export variables and like drag and drop style like ways of making scenes, and I would rather do it the way I was showed in the last one, which is just all programming. It's all in the root nodes. You don't drag and drop anything. Everything is done in code. So after this last tutorial, I figured I would start fresh and try and create a game that I wanted to create of the games that I like. Some of my favorite games are games in which you start out very, very weak, and by the end of the game, you're a god. Games like Vampire Survivors, Mega Bonk, and even games like EDF, where you start out with basically nothing, but as you play, you get stronger and stronger until you become unstoppable. And this game loop, to me, is always fun. It doesn't matter if it's in a tower defense game or if it's in a 3D game like EDF. It's always fun. But immediately I started having problems and realizing I had problems to solve but no idea how to solve them. So before I show you how I solved them, I'm going to show you the problems I had. The first being I could not get more than 175 entities on screen at one time, character body nodes at one time. I won't show it because it'll probably bog down my whole computer and maybe even crash my recording or whatever, even the game engine or everything. But yeah, basically I couldn't get more than 175 or else everything would basically turn into a 1 FPS game. But it didn't take too long to figure out that it was the physics that was causing the problem. If I turned off the physics, everything would run, everything would run fine. But the problem would be that there was no physics now. Things couldn't like collide or anything like that. I decided to watch a YouTube guide on how to make a Vampire Survivors game. So if you go to YouTube and just type a Vampire Survivors clone in Godot, you'll find this tutorial. But I did not like this tutorial either because it's very, very code heavy without explaining the code at all. And I knew I could basically do the same thing it was showing, but much simpler using nodes instead of code. I did learn a few things from it, so I'm not going to talk badly too much about it, but I realized that it would still have the same problems. It uses a character body 2D for the enemies, and it would still be capped at 175 on total on screen, which, just for comparisons, Vampire Survivors, when you reach the end of the level, there's at least 300 entities on screen. So if you really wanted to make an actual Vampire Survivors clone, you have to figure out a way to get more entities on screen. I did a bit of research into why this happens, and it's because of the player character node. It has a lot of built-in physics, and that includes things like collision and velocity and like all the things that the character body can compute. And what happens is when you call the function move and slide, it calculates all of those physics-based things. And what happens is like it eventually just reaches a threshold where it's trying to calculate all those physics properties for everything on screen. And if it's collisions, it's trying to calculate collisions. It's trying to do everything, and it just bogs down your whole computer because it just can't do that many calculations at once. I did come up with a very, very simple solution to solve this, but before I did that, I spent days trying to figure out a solution to this. One of the solutions is how other games handle this, and like RTSs and Total War games and stuff like that have like hundreds, if not thousands, of units on screen at one time, and everything seems to run smoothly. And what I found out is that most of them use some sort of spatial partitioning. I'll leave a link in the description of a really good article that basically explains how this works. But I soon realized I was way over my head trying to set this up. And I did try to set it up. I had a very crude version. But you basically have to make a grid, and then in that grid you have to determine the logic of everything that's in that grid. And it basically turns a physics problem into a CPU problem. But there's a really good read that I'll just put in the description if you want to learn more about it. So the only solutions left is either deal with a player cap of 175, where nothing more than 175 can be on screen, or take away the physics somehow. And one of the suggestions that I read somewhere was just to use an area 2D. Area 2Ds are just an area. They don't have any physics or anything like that. So as long as you could write the logic or write what you wanted to happen, you could have. It seems like a lot of area 2Ds on screen. But yeah, what you're seeing here is literally all that is required for an area 2D to move towards the player and not overlap. Just briefly explaining how this works, we have a player variable at the top that gets the first node in the group player, which I put the player scene in the group player, and the move towards player function is what is run every physics frame that tells the enemy to move towards the player and push any overlapping areas away. In the first line of the function, you create a variable called direction, and you assign this variable the normalized vector towards the player. Then in the next line, you're assigning the position of the enemy scene to the direction variable, which means every physics frame, the position of the enemy scene is changed based on what direction the player is to the enemy scene. You can look up the documentation and experiment with the direction to method, but the main thing to understand is that you're pointing towards what you want to point to, then changing the position of that scene based on that value. I came up with this first part of the function, but the for area, the for loop, is something that I had help with AI. I could not get the area 2Ds to just bounce off of each other. I knew I had to use this get overlapping areas, but I didn't know how to do it in a way that when the areas overlap, they would push each other and not just go the complete opposite direction. What would happen is they would overlap, and then I got it to go the complete opposite direction, but I didn't know how to make them go back to the player. So AI came out with this very simple, it's the same method that the direction uses, but you're doing it for the areas, not just towards the player. But yeah, that whole thing creates like a push away effect, and because there's no physics in it, everything just runs fine. So with the issue of movement sorted out, creating waves and how they spawn I knew wouldn't be a huge issue, so I just moved on to the next big issue, saving the game and creating a system for random choice with the weapons and power-ups. But I figured I would start with saving the game. So I went to the lesson adventure game and tried to see if I could save the player location to disk. So when I boot the game up, it remembers the location of the player. If you Google Godot save function example, you will basically get this exact example I have on screen. I wanted to show a very basic example of the save function and how it works before I show what was suggested to me on how to properly save games. This save function is just saving a variable called player location to disk, which is a vector 2. And the load function, when the load function is called, it is reading the data that was saved and assigning the player location variable to whatever was saved. I think this demonstration will be way more clear. So you have the player position, which is a vector 2, and this is constantly being updated anytime you move the player. And you have the global variable that we created in the auto load. Autoloads are basically singletons. I won't go over them in depth, but a Google search or a video on how to set them up is super easy to explain. But what creating an autoload does is allow you to have a scene or a script that is global. The autoload starts as soon as you start the game, and every scene in your project can access the functions and variables in that autoload. So this is where the save and load function is going to go, and any function or variable that we need to have project wide. In this project I named the autoload scene manager, so hopefully that makes the code easier to follow. Without showing you a bunch of scenes and different spots in the code, the entire idea of how this works like this. In the process function of the game scene, the local player position is constantly being assigned to the global variable called player location. This function is updating the vector2 location of the player every frame. So the next step is to save the global variable player location so we can load it when you want it. So looking back at the save function, you can kind of already see what's happening. When I call the save function, this global variable gets saved to disk, and when I use the load function, this variable gets assigned to whatever was saved. This is a very bare bones way of doing this. I save variables in dictionaries now, which I will show later, but this is just for testing purposes. From what I read, this is not actually how you're supposed to set up a save and load function. For testing purposes, I just created a giant save button and set up the signals so that when the button is pressed, the save function is called. I've learned to litter my code with print functions at the start, middle, and end of functions to make sure they're all working as intended, as well as printing variables to make sure they're being updated or the proper variables. You can see in the bottom left there me just printing out everything. As far as I can tell, it's best practice to put the load function inside the ready function of the global autoload script. That way when the game boots up, since the autoload is automatically loaded, the ready function runs as soon as the game boots up. All the variables are then reassigned to whatever was saved. So the last thing to do is just make sure somewhere in your game's code that the player position is reassigned to the correct vector2 location that was loaded into the global variable at game start or whenever. This is just a very basic example. I'll show you how I save and load games now that I somewhat know what I'm doing. So just to make sure I knew how the save and load function really worked, I went and made something a little bit more dynamic. In the other game I was working on, I created a scoreboard that saves the score at death. When the game starts, the load function is called, so all the correct variables are reassigned, and it works. So to do this was pretty straightforward. I just created a global variable called scoreList that is an array. This add score function is in the global script, but I very well could have just put it in a local scene. But what this is doing is just taking whatever number that is passed to it, adding that number to the array, sorting it from highest to lowest, and only allowing a total of 5 scores. And then I just took that score list array and printed it to a label node. To save the score list so it can be loaded at game start, here's the save function that gets called when the player dies. After doing a lot of research, I'm going to be using a dictionary to save all my game data. What this does is basically allow you to expand your save function very easily, and your load function, just by adding to the dictionary as you need. And since you can basically have any type of, any data type in a dictionary, as far as I can tell, there's really no limit to what you can save. Here is the load function, and just like the save function, I can expand on this load function as well. So that is the downside of using this. You are going to have to add to the save and load. But as far as I can tell, this is the best way to save and load your game. But yeah, this was a huge topic to understand and wrap my brain around, because you essentially have to know how this works before you can start writing game progress. An example that might make it pretty clear is using booleans, right? Just for an example, let's say you create 10 booleans and label them level 1 through 10, and you assign these variables false by default. In your save function, you would want to write these variables so that all of these variables get saved to disk every time you call the save function. But let's say in your game's code that you've completed level 1, and at the end of the level 1 you switch the level 1 boolean from false to true and then call the save game function. That variable then gets saved as true and not false. And as long as you call the load function at the game start, that variable will then be loaded as true. So using this, you can basically create logic in your code to check if the boolean is false or true and act appropriate. So I spent a long time trying to come up with the best method of checking these global variables and writing if statements to where it would check these global variables and act appropriate depending on if they were true or false. Or another example is the score. Once the score hit a certain limit, then do this. And Godot doesn't have any kind of built-in watcher function, so the only good place you want to flip variables, add to variables, or listen or watch to variables is in Godot's signals. If you try to write if statements in the process function of a scene to check these global variables, it just gets really messy. And by messy, I mean a crazy amount of bugs. So I kind of decided that this shoot 'em up game is going to be the one I'm going to be working on to get a full demo going, or at least work on it to get all the systems up and running that I would want or that I wanted to work on. I reworked a lot of the code and decided it would be best not to mix behaviors. I started writing the game so that every scene handled its own logic and behavior. The player code controlled everything the player can do. The level up UI controls everything to do with leveling up. The enemy scene controls everything the enemy does, and so on and so on. That in itself took a while, because rewriting everything with that in mind just took a while to do. And I thought it might be a good idea to merge all the game mechanics that I was wanting in the Vampire Survivor clone into this game. I can't really think of a side-scroller shoot-'em-up game that has those Vampire Survivor mechanics, at least in the sense of this classic arcade style game. So the final thing I wanted to show in this video is the level up system that I got working. It took a while for me to figure out how to do this. It's not originally the way I wanted it, but I know how I can get it to work as close to what I want as possible and have an extra layer of mechanic and fun to the game. So the issue was I didn't know how to create a level up system in a sense that I could unlock weapons and they get picked based on a random pick. And I'll spare you the week's worth of testing and debugging, and I'll just show you how I got it to work. So before I go into detail, I'm just going to give a brief overview of what's happening. There's quite a bit of things that are happening, so please just bear with me for a second. So the first step was I created an XP scene, which is just an XP orb for right now, and it drops a sprite with an area 2D. When an enemy dies, it spawns this scene on the enemy. When the player enters the area, there's a global variable called total XP that gets a value added to it. I figured this was better than just using the score because it gives the player something to do. When the XP variable reaches a certain amount that I tell it to, the game will show a level up screen. In this level up screen, for now, the game will pick a weapon from a list of weapons that are unlocked. When the player picks the weapon, a function is called that equips the weapon to the player. Then the game removes that selected weapon from the list so it can't be picked again. Please ignore the ugly UI and the scenes that I'm using here. I just wanted to get the system up and running, so everything is placeholder right now. So to start explaining this, I basically made a dictionary for everything relating to weapons that I can expand as I need. And I made a list, or I should say an array, that adds these dictionary keys that I can manipulate how I like. On screen, you'll see these 3 dictionaries for things about the weapon scenes. The weapon scene itself, the icon of the weapon, and the weapon description. For now, all of my unlock booleans are set to true, but like I discussed earlier, you can set up whatever you like to flip these variables from false to true and then save to create a progressing system. And you'll notice that all the keys of these dictionaries are the same relating to each weapon. They are the same keys, but each key is in its own dictionary. And that's the key to how all this thing works, no pun intended. Once I realized you can use the key of a dictionary to get the value that is associated with that key in that dictionary, this is a way that I can get anything, anywhere in code. So just to drive home what's happening inside this weapon dictionary function, the key rocket is being added to the unlock weapon list dictionary, and its value is the rocket scene itself. The next line, I'm adding the key rocket to the weapon icon list dictionary that has the value of a JPEG in the project that is just an image of the rocket. And I'm adding the key rocket to the weapon description dictionary, which is just the text for the rocket. I'm adding the same key to 3 separate dictionaries. That way, you can just use a variable or a list or whatever. As long as it has the string rocket, you can use it to get values of each of these dictionaries. So just moving over to the list here in the level up UI screen, I'll do my best to describe what is happening, but in a nutshell, because the keys to the dictionary are all strings and they're all the same string, we can use the same string in a list to get values of all the dictionaries in the global. This is a lot to keep track of, but by using this .keys method, we can rip the keys of the global dictionary and stick them into a list. Or array, I keep saying a list. All of the dictionary keys we made in the global are now in these arrays. For now, the array just has the string, rocket, and plasma, but as you develop the game and make more weapons, you can make more dictionaries and add to those dictionaries and so on and so forth. Because I have a list now that are basically the strings of the dictionary, the keys of the dictionaries, you can manipulate them however you like any other array. I just use the pick random method to pick a random string from the list. But I know there are ways you can have a weighted system too for like rare items. So there's a lot to this prime weapon function here, but I'm just using a random string I picked from the array that I made that stuffed all the keys into, and using that string I can get the value of the dictionary and assign it to a new variable. Because I'm doing this, I now have a variable that is linked to the value of that dictionary. Alright, hopefully I can explain this line by line and it'll make more sense if you don't already understand it. But line 24, there's a weapon list array that we're sticking all of the keys from the global dictionary unlocked weapon lists into. We're assigning those keys to that weapon list array. Line 37, we're taking that weapon list array that has all the keys, which are strings. We're picking a random string from that list, and we are assigning that randomly picked string to a variable called random choice 1, which is just a blank variable created at the top of the script. Line 38, we're passing in the random choice 1 variable, which has the string that we randomly picked, and we're passing that into the dictionary global state unlocked weapon list, which just has the scenes of the weapons. So we're basically using the string of the list to get the value of the dictionary, and then we're assigning that to a blank variable called random choice 1 scene. And hopefully you can see what's going on here. I'm just using the string that was randomly picked to pass into each of the dictionaries, and then I'm either assigning them to a variable like in 38, or I have an onReady variable like what is in line 39, weapon icon 1.texture. That is just a texture rec, so I'm basically uploading the texture in the dictionary to the node in Godot, which is a texture rec node. And this is basically how the system works. The if statements in this function are just safeguards to make sure there's actually something in the list before executing the code under it, and the while loop is just there to make sure that the second choice isn't the first choice. You know, if the second choice equals the first choice, just keep picking a random until the second choice does not equal the first. Alright, so I won't go over this UI in too much great of a detail because that could be a video in of itself, but I will kind of explain how I got it to show up here. So these nodes are basically what I'm pushing all of the information of the function into, but the main takeaway is that the children are always rooted to the parent. So you can see this weapon sprite here is in the center of this texture rec, which means that sprite will always be in the center of this texture rec no matter where it moves on the screen. That texture rec is a child of the weapon 1H box, which means these texture recs and the sprite will always move with this HBox container here, and so on and so forth. You can see how everything is just centered, and anytime I move this, everything else moves, and it just works the farther down you go. I watched a few different videos on UI and I'm still learning the basics. It's something I definitely need to work on and make it look better, but by using containers you can create a scaling UI that's always centered on the screen or centered wherever you want. And just briefly, here are the other functions I use in the UI. Their names are what they do. I'm basically turning the UI visibility property on or off depending on when I call the function, and pausing and unpausing the game is pretty simple. You can just Google how to do that. But just briefly, this is what happens when the choice 1 button or the choice 2 button is pressed. I basically equip the weapon to the player using a function inside the player scene. So I'll put the equipped function in the player scene next to the button in the level up UI scene, and hopefully you can see what's happening. When I press a button, I'm taking the packed scene that was assigned to the variable random choice 1 scene or random choice 2 scene depending on what is pressed, and passing it to this function. The equipped weapon function takes that packed scene and assigns it to the first weapon variable, which is just a blank variable created at the top of the script. You can see in the function the plasma scene is set to the default value, and that's just because I haven't made like a beginner weapon. I have to pick a scene to start shooting first. When I create a beginner pea shooter style weapon, I'll set that to the default value. That way when the game starts, the default value is used and no need for the UI or anything like that for a beginner weapon to be selected. The shoot current weapon function is called every time the player presses the spacebar, and it just spawns in the scene we assigned to the variable inside the equip weapon function. It's a lot of steps for this weapon system, but I can't think of a better way to do this. The main struggle was just getting things to logically work together, and the list dictionary method's the only thing I can think of where I can manipulate the list and have a single string point to all the dictionaries I need. There's still a ton of experimenting to do. There's still questions I'm thinking about on how I'm going to do it, and I think it's just best to just experiment to figure out if I can do them. I would like a multiple systems setup, like weapons, shields, utility, things like that, and getting them to work together is, I know it's going to be a challenge, but hopefully it'll logically make sense the more I work on it and the more I write functions, and setting up the logic for those functions to work together. It's gonna be fun, but hopefully as I expand it, I'll see different ways to improve it. If anybody has any ideas or any setups they've known or they would like that they use, just please write a basic description in the comments, and I'll look into it. But as I said before, this doesn't totally work the way I want it, because I still don't know how to level up a weapon that I've already selected, like Vampire Survivors style, where I change the attributes of a weapon, and how to logically implement that to where when I select a weapon, it goes into a pool of selected weapons and then it injects that into the list so that a possible level up selection is selected. I'm sure it'll make more sense as I work on it, but I just need to work on it. For now, I've opted just to use a linear level up system, meaning at the start you select your weapon platform, like a rocket platform or a laser platform, and that choice determines your weapon list. I can make a function to do this just like I did with the weapon select here. Then at a certain amount of XP, you choose a primary weapon that's based off your weapon platform. Then at a certain amount, choose your defense system, and so on and so forth. I can basically make it to where you build your own ship as you play through the level. As you play through the game, you can unlock more weapons and more weapon platforms, which allow you to take on harder bosses, and this is basically the formula of those shoot-'em-up roguelikes. I know I can do it just by making scenes for everything, but I would like to do it dynamically by making a system that keeps track of everything I've selected, and I can level up a weapon or create a bunch of stats that can change based on what the player picks. But I don't really know how to do that yet. It's just gonna take time of me working with dictionaries. There are some good tutorials out there, but they're also bad tutorials. They don't explain the system. They just say do this, this, and this, and here you go. There are so many little things that I've learned since my last video. I just can't show everything. But before I end the video, I think there's one last thing I should show that solved a huge bug and I know I'll be using in the future. So just briefly, this function I moved from the player script to the plasma weapon scene so it can handle all of its own behavior. And what was happening is to get the 3 bullet effect when you shoot the weapon, you have to spawn in 2 other plasma bullets. So what was happening is that it created a runaway loop that would crash the game because a forever loop was basically being created by this function. When I pressed the spacebar, the plasma weapon scene would spawn. When it spawns in the game, the ready function would run, which would execute the special attack function. That function would spawn in more bullets to create that 3 bullet effect. Well, those 3 bullets are the plasma scene. So that means the ready function was called when they spawn, which means the special attack function got called, which spawns in more plasma scenes, which means the ready function would get called again, and you can see the problem. So the solution was pretty simple. On line 33, you can see me instantiating the plasma scene, and then the next line, you can see me changing a variable. I didn't know once you instantiated a scene to a variable, in this case the plasma instance variable there, you can change whatever variable inside that scene you want. So the shots fired, I'm basically changing from false to true, and this is how I made a flag system. You can see in the ready function now that there's an if statement that if the shots fired equals false, then execute the special attack. This basically means the bullets that get spawned inside the for loop have this variable changed to true, which means the if statement doesn't run, which means they don't spawn in any more scenes. So after you instantiate something, you can change something or use something inside that scene. And line 37 is when you actually spawn in the scene with all the changed variables. So this just creates a very easy to use flag system. I need to experiment with it more, but just knowing this means I can have the scenes themselves or any scene that is instantiating another scene change variables like speed and position and whatever. But yeah, I think that's a pretty hefty video. I'm probably going to wait until I have something way more substantial to show for my next video, a full-blown demo with all the systems I want up and running. I'm probably going to use pre-made assets because art is very hard. I've tried to make pixel art, and art is where I am severely lacking. So anyway, I think that's about it. Alright, later.